Imagine the year 2050. Humanity has crossed boundaries once thought impossible. Cities on Earth are powered by clean energy. And in the night sky, bright points of light aren't just stars, they're human outposts on the Moon and Mars. This is the future NASA is planning, a future where exploration is not a dream, but a daily mission. NASA's 2050 vision is one of the most ambitious plans ever created in human history. It's a roadmap that extends far beyond Earth's orbit, aiming to make humanity a multiplanetary species. From advanced spacecraft to artificial intelligence astronauts, from lunar bases to Mars cities, NASA is shaping a future that could change what it means to be human. Let's travel through this vision, step by step, to understand how NASA plans to explore, survive, and thrive in the next 25 years. In the early 2020s, NASA began the Artemis program, a new era of lunar exploration. The goal wasn't just to return to the moon, it was to stay there. The Artemis missions were designed to establish a permanent lunar base, a research station where astronauts could live, work, and prepare for deep space journeys. By 2030, this base became humanity's first home beyond Earth. Solar-powered habitats, robotic assistants, and 3D printed structures made from lunar dust formed the foundation of this new frontier. But why the moon? Because it's the perfect testing ground. NASA's engineers know that if humans can survive sustainably on the moon, then Mars, and even deeper space, becomes possible. Every mission to the moon is a step toward the red planet. Behind the scenes, NASA scientists were already working on the next big leap, the Mars mission. Unlike the moon, Mars is far more distant and dangerous. The average round trip could take 2 to 3 years. Radiation, isolation, and communication delays make it one of the toughest challenges in human history. Yet NASA believes the first humans will set foot on Mars before 2040. In this future vision, astronauts won't rely on Earth for everything. NASA's plan is to use the resources of other worlds, what they call in situ resource utilization. On Mars, astronauts will create oxygen from carbon dioxide, grow food using Martian soil, and build shelters using local materials. This means future astronauts will not just visit other planets, they'll live there. By 2050, NASA envisions small, self-sustaining colonies on Mars, connected with Earth through high-speed laser communication and AI-controlled cargo ships that deliver supplies every few months. These colonies will be the first true off-world human settlements. To make this possible, NASA is developing new generations of spacecraft. Traditional chemical rockets are being replaced by nuclear-powered propulsion systems, engines that can cut the travel time to Mars nearly in half. With nuclear thermal rockets, spacecraft could travel deeper into the solar system, reaching destinations like Europa, Jupiter's icy moon, or Titan, Saturn's mysterious satellite. But it's not just about where we go. It's also about how we go. NASA's future missions rely heavily on robotics and artificial intelligence. Future spacecraft will have onboard AI systems that can think, react, and repair without human help. Robots will mine resources, construct habitats, and even explore areas too dangerous for astronauts. In NASA's 2050 vision, humans and machines will work together as a single team. The boundary between astronaut and AI will blur, creating a new kind of explorer. Another key part of NASA's plan is the Gateway, a space station orbiting the moon. Think of it as a space airport, a hub where spacecraft can dock, refuel, and prepare for longer journeys. The Gateway will serve as a launch point for Mars and other missions beyond. It's a symbol of how NASA sees the future, connected, cooperative, and continuous. By the mid-2030s, NASA also expects international cooperation to reach new levels. Countries like Japan, India, and members of the European Space Agency are already working side by side with NASA. In 2050, space will no longer be the race it once was. It will be a shared dream of humanity. Meanwhile, technology on Earth will continue to evolve in harmony with space exploration. Artificial intelligence, renewable energy, and advanced robotics will all contribute to making space travel safer and more affordable. NASA also envisions space as a place not just for exploration, but for economy. In the future, companies will mine asteroids for rare metals, build solar power stations in orbit, and even offer space tourism to ordinary people. This will create a new space economy, generating billions of dollars and endless innovation. But NASA knows that with great ambition comes great responsibility. As we expand into the cosmos, we must protect the environments we explore. Future missions will include strict planetary protection rules, ensuring that we don't contaminate other worlds with Earth's bacteria or damage alien ecosystems before we even discover them. By 2050, NASA's dream is clear: to build a sustainable path for humanity beyond Earth. A future where children born on Earth can look up at the night sky and know that somewhere out there, humans are walking on another world. This is not just science fiction anymore. This is the roadmap of the next 25 years. Soft background rise, closing line. And as NASA looks to 2050, one question remains. Not if we'll reach the stars, but how we 2050. The dream of a multi-planet civilization will no longer be a distant idea. The moon base will be thriving. Not just a research station, but a busy hub of human activity. Every month, rockets will travel between Earth and the moon, carrying scientists, engineers, and supplies. The lunar base will have laboratories for biology, physics, and space medicine, testing how humans can live longer and healthier in low gravity. In this future, the line between space and home will begin to blur. For some, Earth will be a birthplace, but not necessarily home. Children born in space will grow up under different stars, learning both Earth's history and the story of human expansion into the cosmos. By the late 2040s, NASA's focus will shift further to Mars cities. The first colonies, built with robotic help, will grow into small connected settlements. Each dome will have its own ecosystem, producing oxygen, recycling water, and growing food. Robots will maintain the infrastructure while humans explore deeper regions of Mars, collecting samples and searching for ancient life. NASA scientists believe that signs of microbial life might already exist beneath the surface, trapped in ice or underground water reserves. If confirmed, this discovery would be one of the most significant in human history, proving that life is not unique to Earth. In 2050, communication between Earth and Mars will be almost instant, thanks to quantum data links and laser-based transmission systems. Virtual reality meetings will let scientists on Earth work side by side with astronauts on Mars, as if they were in the same room. Back on Earth, spaceports will become as common as airports. Reusable rockets and automated launch systems will make travel to orbit faster, cheaper, and safer. For many, space tourism will no longer be science fiction. It will be a vacation option. But NASA's 2050 vision goes beyond Mars. It looks to the outer worlds, the icy moons of Jupiter and Saturn, where life might exist under frozen oceans. Missions to Europa and Titan will search for alien chemistry, using robotic submarines to explore beneath their icy crusts. These missions will mark the first steps of humanity into the outer solar system. Meanwhile, NASA will continue to study exoplanets, worlds orbiting distant stars. With the help of next-generation telescopes, scientists will detect the colors and atmospheres of alien planets, searching for signs of oxygen, water, and even civilization. By mid-century, we may finally discover a planet that looks like Earth, and possibly one that hosts life. Artificial intelligence will play a massive role in this new era. Future spacecraft will think, plan, and explore on their own. AI co-pilots will make decisions in real time, reacting to cosmic dangers, asteroid fields, and unexpected signals. These intelligent systems will act as both companions and protectors for human crews. Some missions will be entirely robotic. Self-aware probes that can travel for decades, powered by nuclear or solar energy, sending back data long after humans have moved on. NASA calls this the interstellar network, a system of intelligent explorers reaching beyond our solar system. One of the boldest parts of NASA's vision is the idea of human hibernation, deep sleep technology that could allow astronauts to travel for years without aging or resource limits. By 2050, this technology may become reality, making missions to the outer planets and even nearby stars possible. But beyond the science and the technology, NASA's 2050 vision is about something deeper, the spirit of discovery. It's about curiosity, unity, and survival. It's about proving that no matter how far we go, humanity will always carry its dreams with it. In this future, the International Space Station will evolve into a larger, modular system, a gateway between worlds. New habitats will orbit Mars, the Moon, and maybe even Venus, each one a symbol of human endurance and ingenuity. Back on Earth, the lessons from space will transform everyday life. Technologies developed for space habitats, like air recycling, renewable energy, and sustainable agriculture, will help solve climate change and resource crises here at home. NASA's innovations won't just take us to space, they'll rebuild Earth itself. By 2050, education will also transform. Students will attend virtual field trips to the Moon, perform experiments in zero gravity through robotic arms, and even talk live with astronauts exploring Mars. The end.